Okay, so in this video we're looking at the calculator skills that will be required for the Unit 3 examination. So as you can see on your screen, we'll start by looking at solve_n. We'll look at solving simultaneous equations including infinite solutions. We'll look at complex number calculations, higher order matrix entering calculations. I know you can already do this, but we'll look at the most efficient way. We'll look at solving polynomials over C, vector cross products and vector dot products all on your calculator. Okay, so if we scroll down and we start with solve_n, obviously the whole idea of using solve_n is that we can solve most equations simply, and it's really easy to do because we just do it straight in our run matrix menu. Okay, so in order to do that, obviously we want to go into our menu, choose run matrix, so exe there. If we want to, we can delete everything off this page. So F2, delete everything, and we're starting from fresh. So what we're going to look at here, run matrix menu, we're going to choose option, calc, solve_n. So it's as simple as that, option, calc, which is F4, and solve_n, which is F5. So solve_n pops up on your screen. Now all you need to do in there is enter your equation you want to solve. So when we look at these two examples, I've got solve the following. I've got 0 is equal to x squared plus 5x plus 6. We already know the answers to that are -2 and -3. But let's enter it. So x squared plus 5x plus 6. Shift. And we have to find the equal sign. See, it's down here on the decimal point. Equals 0. When we close that bracket up and we hit exe, it'll always give us this warning, more solutions may exist. We hit exit and we get our answers. We get, that's not ideal, we get x is equal to -3 or x is equal to -2. So really nice and simple there. When we look at B, we've got a more complex equation. Now we could go and rearrange this and isolate, we'll put everything to one side and make it equal to 0, but it's not necessary with solve_n. If we go F5 again for solve_n, and up here I've messed these two up, it's just dawning on me now. This should be F5, and this should be F4. Okay, it should be F4 for calc and F5 for solve_n. Alright, so we enter our equation. We've got 5x cubed take 3x squared plus 2x take 7. Now the equals is very important, so shift dot gives us equals and 3x take 2. Close up our bracket, hit exe, and it will calculate all the solutions. In this case, for this cubic, there's only one solution. So x is equal to 1.32274. Alright, solve_n is a good way to solve something when we have a tech active question and you just want to get the solution to something, some equation that's rather basic. Alright, so that's solve_n, a very useful option in your graphics calculator. The second thing we're going to look at is solving simultaneous equations. So we've been doing this a lot by hand, but obviously we want to have a process where we can do it on the calculator as well. This will be done in the menu equations. So if we go menu equations, we'll have the option to choose F1 for simultaneous, and then for however many unknowns we have, we can select that. So for these two scenarios, I've got 3 unknowns, so x, y, and z. As long as we can enter it in as an augmented matrix, it'll be nice and easy. So if we set this one up as an augmented matrix, we've got 2, 3, -2, and the answer is 2. We have 3, 0, 2, and the answer is 9. And -2, 5, and -2, and the answer is 2. Now, if we enter that in, we should get our answers for x, y, and z. So 2, 3, and then finally 2. So we hit solve. Look at that, nice simple answers, 1, 2, and 3. Beautifully set up, well executed. There's our answer that solves our simultaneous equation. Now, every time you're doing this in an exam, it would make sense to check your answer. So entering that in and being efficient and quick with it would be a very good skill to develop before the examination. Now, when we're looking at question 2, we've got different set of values, but this one is set up to give infinite answers. So if we set this up as an augmented matrix, we've got 12, 20, 32, and the answer is 220, 16x, 12y, 28z, and the answer is 176, 8x, 28y, 36z, and the answer is 264. When we go to solve this, so just give me a second to enter. So there we are, miraculously entered. We hit solve, and you'll see that it'll say here that we've got infinitely many solutions. So that means that we can only get the solutions in terms of one of the variables. So we've got x is 5 take z, we've got y is 8 take z, and we've got z is equal to z. Now, for these types of scenarios, once you get to that point, that might be the end of the question, but if it's an application, you're likely going to have to decide on some values that will work with z. So if I was looking at this problem, I would say that z is an element of a set of the numbers 0 through to 5, as long as we have to maintain positive or 0 values of each of these variables. So if I put 0 through to 5 in, I would get 5 sets of different solutions. Okay, you can see how easy it is on the calculator to do that. So make sure you're able to calculate, use your calculator to solve simultaneous equations. When we look at complex number calculations, the calculator is really good for doing this. If we go into the Run Matrix menu again, so we can enter in any complex number using Shift and 0. So if we hit Shift and 0, it enters I, which is the imaginary number. Now, it's smart enough to keep these two things separate. 3 plus the imaginary number is still 3 plus I. Now, if we want to then square that, we get 8 plus 6i. So we can perform these calculations very quickly and easily, if need be, on our graphics calculator. So if I want to look at 3 plus I to the power of 5, 3 plus Shift I all to the power of 5, and there it is, negative 12 plus 316i. Good way to check your calculations, or a good way to perform calculations in a TechActive question. Now, if we look at this question here, it's a little bit more complicated. We've got a couple of brackets over a fraction, and we've got a complex number in trig form. Make sure if you're entering in trig form, you'll have to expand it, and you'll have to make sure you're in radians. If you don't remember how to make sure you calculate in radians, you hit Shift and then Menu, and you come down to the angle. Angle is what you want to be in radians. If you're in degrees, you'll have to hit F2 to change it back to radians, and then we can go back and we can do our calculations. So if I was doing this on my calculator, it would be straight entry. I'd have my bracket, 1 plus Shift O for I to the power of 5, multiplied by bracket. Now we've got 2 cis, so 2 cos pi on 6 plus 2 sine pi on 6. And this part is imaginary, so we have to go Shift I. And then on the denominator we have 2 plus 2 root 3 I. Oops, you don't want that to be inside the square root. I. And that's all raised to the power of 3. Now you just have to be careful that when you've entered this complex number in the trig form, that if you just have the bracket and then I, it won't work. It'll have a little bit of a hissy fit. You need to put in your multiplication sign there. So 2 sine pi on 6 times I. When we hit EXE, then we get our answer. So that means our solution here will be -1 plus root 3 on 16 and 1 plus root 3 on 16i. Now the unfortunate thing is this will never give you an answer in trig form. It will only give you the answer in component form, but it's still a good way for you to check. Okay, so pretty straightforward complex numbers. You don't have to have your calculator in a complex mode for this to work. So if I go into shift menu, you can see when I scroll down that my calculator is still in complex mode real. It only needs to be in that a plus bi when we're trying to solve later on, and I'll show you that when we look at solving polynomials over C. So the next skill is higher order matrix entering calculations. My recommendation with this, we'll just delete everything on our screen, is that we use this F3 matrix vector menu. Okay, so it will make things easier, particularly if we're having to use matrices over and over again. So going into that matrix, we can start by entering the matrices. So we'll look at this first example. We've got a Leslie matrix, a population matrix, and we're looking at calculating the population after 10 years. So we want the total population and the generational population. This one gives us our generational. This one gives us our total. So we're going to do both of these. So in order to do this for these Leslie matrices, we'll need the Leslie matrix, obviously. So the Leslie matrix will be matrix A, and it's a 4x4. So I'll just enter in the information. Okay, so that's the Leslie matrix entered. In matrix B, I'll enter my initial population matrix, so that's a 4x1. And so I've got 1150, I've got 900, I've got 450, and 300. Now I do need another matrix. I'm going to need the 1 matrix, and so we use this when we're actually calculating the total population. So this will be a 1/4 in this case. So all we need to do is enter ones. And there's all the matrices that I'm going to need. So I'm going to go back out into the menu. So to calculate this P10 is what I'm looking for. We have to double the population. So we've got 2, and then we've got our Leslie matrix to the power of 10, and then we've got our initial population matrix. So this is going to be 2 by matrix A to the power of 10, and then multiplied by matrix B. When we're looking at calculating the actual population, so P10, not a vector anymore, will be 2 multiplied by the 1 matrix, multiplied by the Leslie matrix to the power of 10, and then the initial population. So 2 multiplied by matrix C, multiplied by matrix A to the power of 10, and then multiplied by matrix B. So let's enter these in. So we've got 2 multiplied, now we press shift and 2 to get matrix, alpha A for the first one. Now we raise that to the power of 10, and then we multiply by matrix B. we hit EXE there and we get our matrix. So you can see that it's 276.07, 157-ish, probably 158. I'll round up to 154, and then 129. So there's our matrix, nice and easy. Now if I just go up and change this, so instead of having to rewrite the whole thing again, I'm just going to enter an extra section in. I'm going to make this 2 times, and we enter matrix C. We do our calculation, and we get our 716.97, or approximately 717 for our population. Now if I had to change this to another year, so let's say it was 50 now, go back up, and we can just go across until we get to the 10, and I change that to 50. So it's really nice and quick. Obviously this is a decreasing population scenario, but you can see the point, nice and easy to enter, and then the calculations, if we go back up and make adjustments, will be much simpler to work with and much quicker. Okay, so in the second one, we're looking at a dominance matrix, and we're looking at calculating the first and second order ranks. So remember, rank 1 will be the dominance matrix multiplied by a 1 matrix, and rank 2 will be the dominance matrix squared multiplied by a 1 matrix. Okay, so I'm going to go and re-enter my matrices. I'm going to enter them in D and E. So matrix vector menu, matrix D will now be a 6 by 6. I'm going to fast forward the entry here. So there's our dominance matrix entered. And in E we'll have to put our 1 matrix, which will be a 6 by 1, and all the values will be 1s. Now it's just going to be matrix D multiplied by matrix E, and matrix D squared multiplied by matrix E. So let's do that now, nice and easy. So we have matrix in matrix D multiplied by matrix E. There we have our answer, so we can straight away write that in. I may have to scroll up, no. 3.522, 2.50, and 4. Now again, nice and efficient, we can go back up into what's already typed out, and we can add that square at the end of matrix D, and super quick, 5.25, 4, 4.5, 3.75, 0, and 8. So we have our first order and second order matrices in a matter of seconds. Alright, so working with higher order matrices, I really recommend using that matrix vector menu. It's much quicker, particularly when you're having to redo calculations. Okay, solving polynomials over C. This is where we have to actually go in. So I'm just going to delete everything again, just clear my screen. If we go Shift and Menu, we have to make sure that we're in complex mode, A plus BI. Now, we don't want to leave it in this all the time because it can throw up other solutions to different polynomials we're trying to solve. So you only want to put it in this mode when you're trying to solve these polynomials over C, but it is really straightforward. So if we use this, and we can exit back out, and the equation solver in polynomial, so F2, then we can pretty much solve any of these complex polynomials. So for our first example, we've got x squared plus 1, which is a quadratic, right? And in this, we have a is equal to 1, and b is equal to 0, c is equal to 1. So here we go, second order. We've got 1 and 0 and 1. And now when I hit F1 to solve, you can see I've got my two answers. I've got x is equal to I, or x is equal to negative I. So there's our solutions, our complex number solutions. Now, this next question is a little bit more complex. I'm going to show you a couple of things. Obviously, the last part is we're going to factorize and solve, and we'll use our calculator to do that. Now, if I was trying to sub in this z take 1 take I, show that's a linear factor, one way we can do that is if we add our polynomial into graph. So if we add that in, we've got x cubed plus 4x squared take 10x plus 12. Now if we go back into our run matrix menu and we go vars and graph, which is F4, I can say y1, and I want to sub in, see, because z take 1 take I is a factor, then we can say we want to look to see if z is equal to 1 plus I is a root. So if we sub in 1 plus shift 0 for I, we should end up with 0 to answer. So that does confirm it. Now the idea here is, if you were working this out and you were saying this is 1 plus I cubed and 4 lots of 1 plus I squared, take 10 lots of 1 plus I plus 12, and you wanted to check that your expansion of 1 plus I cubed is right, we can put this in as 1 plus I cubed. Oh, look at that, that is negative 2 plus 2I. What about 4 lots of 1 plus I squared? Okay, that should be just 8I. And what about negative 10 multiplied by 1 plus I? That is negative 10 take 10I. And then we could really easily group these together. So when we look at our real numbers, we can see negative 2 take 10 plus 12 is definitely 0. And when I look at my imaginary numbers, I've got 2 plus 8 take 10, so that's definitely 0 as well. So we end up with 0 here. So we can use that quite efficiently to help us if we need. So now we're going to go back and we're going to fully factorize and solve using a graphics calculator. So we'll go back to equation, we'll go back into polynomial, and we're a third degree because we have a power of 3. And we've got 1 for A, we have 4 for B, that's the z cubed and z squared, we have negative 10, and then we have 12, and if I hit solve here, you'll see that I've got my answers. I've got z is equal to negative 6, z is equal to 1 plus I, and z is equal to 1 take I. And if I wanted to write that in a factorized form, it would be z plus 6, z take 1 take I, and z take 1 plus I, because we'll move these all over so that each of them are equal to 0. Okay, so solving polynomials over C is pretty straightforward. Again, that little thing to remember, make sure you change the complex mode before you do this, but you don't want to leave it in complex mode all the time. Okay, so the final skill is we're looking at vector, cross, and dot products. So we're going to go back to our run matrix menu for this. I'll delete everything again. Okay, so you can find the dot product and cross product by hitting option, matrix vectors, and we can go across twice, so F6 and F6 again. And you can see with F2 we've got a dot product, and with F3 we've got the cross product. Now I recommend when you're doing this, we go back into our matrix vectors. I'm just going to delete these all now. And let's say for vector A, which is 1, 2, and -3, I want to add a 3 by 1 matrix. So we have 1, 2, and -3. And for matrix B, again, it's a 3 by 1 in this case. And I have 3, 2, and -5. So with these vectors, you have to enter them as storage vectors. Now you can do it both ways, and I'll show you. But if I wanted to find the dot product and the cross product of these two vectors, obviously A will just be vector A dot vector B, and we should only get a scalar value, a single numerical value, when we do this. So let's go back out, and we can say option matrices vectors, and we go across twice, and I want the dot product. So see there it says dot product, and we go matrix A. Now we have to put a comma in between, so comma, and then matrix B. We hit exe, and look, there it is, that dot product should be 22. Now if we want to do this a hard way, we can do dot product, and we can go back, and we can enter in using math and matrices vectors a 3 by 1, which is F5, and let's enter our values 1, 2, oh no, it always happens, 1, 2, and -3, put in our comma, and we put in another 3 by 1, and now we've got 3, 2, and -5, and we close our brackets, hit exe, we see we get the same answer. Now for me, I think it's much easier using the opposite approach, but that's up to you now. For B, when we do the cross product, we know when we do a cross product we get a vector answer, so we should get an x, y, and a z value here. So option matrices vectors across twice, cross product is F3, and matrix A, comma, matrix B, hit exe there, and you can see that it's -4, -4, -4. So cross product, which is also the normal, will be -4, -4, -4. Okay, so now when we look at this question, and you'll recognize question 2 from a weekly review, I think it was a week 8 one. Use displacement vectors to calculate your vector normal. So if I look at vector AB, and I know that that's OB take OA, so B take A, we've got 5 take 1, which is 4, -2 take 1, which is -3, 3 take 1, which is 2, and AC, remember that common origin point A allows us to find our vector normal. So AC, which will be OC take OA. And so if we go C take A, 0 take 1 is -1, 3 take 1 is 2, -2 take 1 is -3. So now when we try to find our normal, and we're looking at AB cross AC, this is a tech active question, I'm just going for -3, 2 cross -1, 2, -3. This makes my life much easier. I can say cross product, and I'll have to enter these matrices in first, so I'll do that very quickly. So 4, -3, and 2, and -1, 2, and -3. And so now I can say options, matrices, vectors, cross product, and I've got matrix A, comma, matrix B. And so my normal, my vector normal, is 5i and 10j and 5k. So really, really simple, which allows us then to do our dot product, which we can't do on the calculator. But this would just be r dot n and a dot n. We can't do this one on the calculator because there's unknowns, x, y, and z. 5, 10, and 5. Point A is simply 1, 1, and 1. And 5, 10, and 5 again. So we've got 5x, 10y, 5z, and that's equal to 5 plus 10 plus 5. So 5x, 10y, and 5z is 20. Divide everything by 5, and we get x plus 2y plus z is equal to 4. So you can see it makes that question a lot easier, cuts out the complex part, or the complex calculation part, where we're having to find the determinant of that 3x3 matrix. Okay, so that concludes the lesson on calculator skills. Hopefully that will give you enough of the skills you require for the examination. If there's anything else you need to request, feel free to do so on Teams. Make sure that if you have that old grungy grey calculator, you remind me to bring a newer version of the calculator to the exam, because the old calculator won't do the infinite solutions for the simultaneous equations. Okay, thank you.